Hello students, welcome to Academy's platform for class 11-12 physics. Today we are considering a problem, MCQ type problem from electrostatics. See the statement of the problem. Three concentric metallic spherical shells of radius r, 2r and 3r are given charges q1, q2, q3 respectively. It is found that the surface charge densities on the outer surfaces of the shells are equal. Then the ratio of the charges given to the shells q1 is to q2 is to q3 is, which one is correct, that you have to find out. So there are three spherical cells, concentric spherical cells of radius r, 2r and 3r. This innermost spherical cells is given a charge q1, this one is given a charge q2 and this one is given a charge q3. Then what is the ratio? And it is said that the surface charge densities on the outer surfaces of the cells are equal. Okay, these radius are actually these radii are 2r and 3r of the outer radii of the spherical shells. Then if the outer surface charge densities are equal, then what is the ratio of q1, q2, q3? So one thing we know, fundamental, we know one very important thing in electrostatics, that in such a scenario, when in a metal, inside a metal, the electric field within the metal is internal to the metal, rather is zero in a metal. Why? Say for example here q1 charge is given. This radius is r. This radius is 2r, and the last one, let's let me recall, 3r. So r, 2r and 3r are the radii. So this is r, this is 2r and this is 3r. Radius of the outer surface, you can say. Now here q1 charge is given. Now, as soon as you give q1 charge, the entire charge resides in the outer surface of the sphere, spherical shell. So, when I give a charge q1 to this sphere, its radius is r, say. There will be no charge on the inside surface, because if you take any Gaussian surface, so this is a hollow spherical shell. R is the radius of the outer sphere. Inner sphere radius I am not considering. Some radius is there. Say for example, small r is the radius of the inner sphere. Now, when I give the charge q1 to this sphere, the entire charge resides on the outer surface of the sphere only, and there will be no charge in the inner surface of the sphere here actually. Why? Because we know this is metal spherical shell. So within the metal there will be no electric field. So if you take a Gaussian surface through the metal, it must not enclose any net charge. Therefore, in the inner surface there will be no charge. The entire charge will reside on outer surface. So here in this configuration, the entire charge will reside on outer surface of this inner sphere, inner spherical shell. But as soon as this charge q1 is there on this, there will be induced charge q1 over here in the inner surface of this spherical shell and in the outer surface of this spherical shell. this spherical cell plus Q1 charge will be there by induction. And we have given additional charge Q2 to it. So in this configuration, what is happening? If you take this white spherical shell, inside the white spherical shell, if you imagine a Gaussian surface, spherical surface, it encloses what charge? It encloses this is the inner sphere. This is the inner sphere. Sorry, we call it. Take this color yellow. So, inner sphere has a charge Q1. So here it is minus Q1, here it is plus Q1, and additional Q2 charge you have given. Now, if we take a Gaussian surface like this is Gaussian surface if you consider. Gaussian surface is true in this region, shaded region. Shaded region is the metallic spherical region, shell region. So Gaussian surface encloses net charge Q1 here plus Q1 minus Q1. It is 0. And since the net charge enclosed by the Gaussian surface is 0, so the flux through this surface is 0 and therefore no field. So it ensures, such distribution ensures there is no electric field inside the metal, white metal of this spherical cell, like this, in this region. There will be no field. Now, as soon as there is a charge plus Q1 plus Q2 in the outer surface of the white spherical cell, what will happen? There will be induced charge in the inner surface of the outer sphere, which is equal to minus Q1 minus Q2 minus Q3. Total charge. In the outer surface, in the inner surface of the outermost spherical cell, the induced charge will be minus Q1 minus Q2, not this one, minus Q1 minus Q2. So we started with inner sphere, we have given a charge Q1 and the entire charge resides in the outer surface of the inner sphere, inner spherical cell, and this induces a negative Q1 charge in the inner surface of the white spherical cell whose radius is 2r, and there will be an additional minus plus Q1 charge which is here, free charge in the outer surface of the spherical cell having radius 2r. We have now given plus Q2 charge in the second spherical cell, that means spherical cell having radius 2r. Now the net charge on the outer surface of the spherical cell having radius 2r is Q1 plus Q2. This Q1 plus Q2 induces a charge in the inner surface of the outermost spherical cell which is equal to minus Q1 minus Q2. Now in the outer surface there will be Q1 plus Q2 amount of charge, and we have given charge Q3 also. So charge distribution of the spherical shell will be like this. Three spherical cells will be like this. See, such charge distribution ensures that there is no field inside the metallic region. This region is metal. That means if you consider the outermost spherical cell, So the region bounded by outer radius and inner radius of the spherical cell is the metallic region, and such charge distribution ensures that there is no field in the metal region of the outer shell, because Q1 it encloses net charge which is 0, Q1 minus Q1 plus Q1 plus Q2 minus Q1 minus Q2. And similarly, this region, the shell region of the second spherical cell having radius 2r, this is also metal, and there is no field in the metallic region. And here also there is no field. This is also metal. In this part, the shell region, there is no electric field. So charge distribution is like this. So once we know the charge distribution, it is given that the surface density of charges are equal. So I can write Q1 by 4 pi r square. Q1 by 4 pi r square is the surface charge density in the innermost spherical cell on its outer surface, is equal to Q1 plus Q2 by 4 pi into 2r whole square, is equal to Q1 plus Q2 plus Q3 divided by 4 pi into 3r whole square. Okay, so this is the expression. So what happens actually? So we can write from this Q1 equal to Q1 plus Q2 by 4 equal to Q1 plus Q2 plus Q3 by 9. So you can write 4Q1 equal to Q1 plus Q2. So 3Q1 equal to Q2. So Q1 by Q2 equal to 1 by 3. From here, I can write 9Q1 plus, from these two expressions, this expression 9Q1 plus 9Q2 equal to 4Q1 plus 4Q2 plus 4Q3. So 5Q1 plus 5Q2 equal to 4Q3. But Q2 equal to, in place of Q1 I write Q2. So it becomes 5 into 1 by 3 Q2 plus 5 Q2 equal to 4 Q3. Okay, so 5 Q2 plus 15 Q2 equal to 12 Q3. So 20 Q2 equal to 12 Q3. So Q2 by Q3 is equal to 12 by 20, is actually 3 by 5. So we have found Q1 by Q2 equal to 1 by 3 and Q2 by Q3 equal to 3 by 5. So Q1 is to Q2 is to Q3 is equal to 1 is to 3 is to 5. So this should be the correct answer. So I hope you have understood the steps involved over there. So Q1 is to Q2 is to Q3 is equal to what we have found over there. 1 is to 3 is to 5. So Q1 is to Q2 is to Q3 is 1 is to 3 is to 5. So this B is the correct answer. So this is the correct answer. So basic principle is that whenever I give a charge Q1, here the entire charge will reside on the outer surface of the inner sphere, and it will induce a negative Q1 charge in the inner surface of this spherical shell, and there it will be Q1. And this charge distribution is consistent with the idea that inside the metal there will be no electric field. We have given charge Q2 over there. So as soon as there is a charge Q1 plus Q2 over there, so what happens? Within the metallic sphere, metallic spherical cell, white spherical cell, within the metal part there will be no field, because if you take any arbitrary Gaussian surface, it encloses zero net charge, and therefore the field inside the white part of the second spherical cell, white spherical cell, will be zero. And this Q1 plus Q2 in the outer surface of the middle spherical cell induces minus Q1 minus Q2 charge in the inner surface of the outer spherical shell, and plus Q1 plus Q2 in the outer part. And we have given charge Q3 over there. So this is the charge distribution, and we have used this expression Q1 by 4 pi r square equal to Q1 plus Q2, because Q1 plus Q2 is the net charge in the white spherical cell having radius 2r. So 4 pi into 2r whole square. 2r is the radius of the outer surface of the innermost spherical cell. 2r is the radius of the outer surface of the middle spherical cell, and 3r is the radius of the outer surface of the outermost spherical cell. So these two equations, and then this is Q1 by 4 pi r square equal to Q1 plus Q2 by 4 pi 2r whole square. This is the first equation, and this is also equal to Q1 plus Q2 plus Q3 by 4 pi into 3r whole square. So from this expression, we could find that Q1 is to Q2 is to Q3 is 1 is to 3 is to 5. Okay, so key idea is that within the metal field is 0, and this Q1 charge induces negative Q1 in the inner surface and positive Q1 in the outer surface. So with this idea, we could solve this problem. I hope you have understood. If you have any doubt, you can revert back to us. So with this, I conclude this. Thank you very much for your listening.